Welcome to Spring LIB.
Here, by comparing these two wave function equation, we can get the angular frequency W is equal to, or omega is equal to 10 pi radian per second, and K will be equivalent to 3 pi radian per meter. Sorry, radian per meter. Now, the speed of the wave is found as by using the formula V is equal to omega upon K. So, the answer will be 10 pi upon 3 pi, which is equivalent to 3.33 meter per second. From comparing the equations, we conclude that the wave is traveling to the right along the positive x direction and has a velocity of the form, which is V is equal to 3.33 meter per second, and as it's a x direction, so I can mention it as a I. Now moving towards the part B, in the equation 1 here, let's substitute t is equal to 0 and x is equal to 0.1 meter. So we can obtain the wave function as y 0.1 and 0, because t is 0 and x is equal to 0.1, will be equivalent to 0.35 sine minus 0.3 pi plus pi by 4. So the answer will be minus 0.0548 meter. That is my y. Okay, in the part C, the wavelength of the wave is found from the equation lambda is equal to 2 pi upon k. So the k value is 3 pi. So the wavelength lambda will be equivalent to 0.667 meter. Now let's talk about the frequency of the wave. So it can be found as f is equal to omega upon 2 pi. Also we know the omega value, which is 10 pi upon 2 pi. So the frequency will be 5 hertz. Now in the next part, we are going to differentiate the equation 1. So again we are using this equation, and I'm going to differentiate this equation with respect to time to obtain the wave velocity. Okay, so I can write the wave velocity v is equal to dy upon dt, that I'm going to differentiate, is equal to d upon dt, and instead of y I can write 0.3 350 sine 10 pi t minus 3 pi x plus pi by 4. So the answer will be 0.35, which is the constant value, 10 pi times cos, because the integration of sine is cos, 10 pi t minus 3 pi x plus pi by 4. The maximum transverse speed is the coefficient of the sine function. So in that case, I can write V maximum is equal to 0.35 into 10 pi. That will be equivalent to 11 meter per second, which is the V max.